These rules are a lot to remember, and you'll end up memorizing all of them, trust me. And the way that's going to happen is by using them. So let's get started. Differentiate the function, also known as take the derivative, find f prime. There are a lot of different ways to say this. I'm going to make a point right now to say that differentiate and find the derivative or take the derivative mean the same thing. Okay, I'm sure you got that just by looking at this. Now the word derivative looks like the word derive. Derive, while it's used sometimes in math, it has absolutely nothing to do with taking derivatives. It is incorrect to say, I'm going to derive this function. It's just math people just kind of, I don't want to say they laugh behind our backs when we say that, but they just know it means you don't know. Anyway, so differentiate, take the derivative, totally cool. All right, we're going to do it. F prime of x is equal to, I didn't even read the function. F of x is equal to 60x to the fourth minus 8/3 x cubed plus 10 over 3x to the 1/3 plus 2. And you know what? I'm ahead of myself writing f of x. This 10 over 3x to the 1/3, it's an exponent. And so I want to write this using, I don't want to write it using a denominator that includes a variable. I want to use the power rule is what I'm getting at. So let me rewrite the whole thing. 60x to the fourth minus 8/3 x cubed plus 10/3 x to the negative 1/3 plus 2. You're going to get used to doing stuff like that. That is expressing exponents using negative exponents, essentially. All right, now let's do this. F prime of x is equal to, now we're going to use the power rule for all of these terms except for the last one, which means for 60x to the fourth, the 4 is going to come out front as a coefficient. I'm going to multiply that by 60 and then subtract 1 from the exponent. Next term, the 3 is going to come out front as an exponent. 8/3, I wrote that as a plus, it should be a minus. And then x squared because we subtract 1 from the exponent, right? You're getting the hang of this, right? Look, negative, this time it's supposed to be negative. This is a positive here, but look, this exponent of negative 1/3 is going to come out front. So I have negative 1/3 times 10/3. And this is always fun because even calculus students sometimes forget how to subtract 1. If I have a negative 1/3 and I subtract 1, that becomes negative 4/3. And then the derivative of a constant is 0. And so for 2, I'm not going to write anything at all. Now I'm going to simplify each term. I've got 240x cubed minus 8x squared because the 3's divide out, minus 10 over 9x to the 4/3. I just gave it back in the same way it was given to me. This is the derivative. That's it for this problem. Aren't you glad we didn't have to use the definition for it? Next up, same instructions. We're going to find the derivative for f of x equals the square root of x. We didn't have a root rule or a radical rule, but we do have a power rule. So I'm going to express the square root of x as x to the 1/2. Then f prime of x is going to be, well, that exponent is 1/2, so I bring that out front as a coefficient. 1/2 times x to the, and then when I subtract 1 from 1/2, I get negative 1/2. I'm going to rewrite that as 1 over 2x to the 1/2. And then I'm going to rewrite it further. So I'm going to say f prime of x is equal to 1 over 2 times the square root of x. That does it for that one. You're probably going to end up memorizing this one in particular. The square root of x differentiates to 1 over 2 square root of x. Now I want to point something out. The square root, or the radical, becomes 1 over 2 as an exponent, right? When we had x to the 1/3 in the denominator, it's that denominator exponent that becomes negative. So make sure you're straightened out between what it means to have a negative exponent versus how to express a radical using an exponent.